Welcome back everyone. This is the second lesson recording for IM1, October 27th, 2020. So now we're going to go on to cut number 5 to 9 of the Desmos exercises. Here we go. So we are continuing with grouping like terms. So it says to drag the blue dots to rearrange the like terms next to each other and then enter the simplified expression. So when I look at 9x and 8, 4y, 2y, negative x, and plus 6, which are the like terms? I see the 9x here and negative x. So I am going to bring the negative x right to the front so that 9x and negative x are close to each other. Okay, so then plus 8 plus 4y and 2y. So I know that 4y and 2y should be together and the 8 should be brought to the back. Okay, so let's bring those two guys together. Then let's bring the x's back further so that we have everything together. Okay, so but actually let's keep them separate so that it's easy for us to say which one should be added with which. Okay, so I know that negative x and 9x should be added together. Remember that if there's no plus or minus sign in front of a number or variable, then it's always the default is positive. Okay, so it's positive 9 minus 1. Positive 9 minus 1 is 8. So we're dealing with 8x. So I am going to write 8x here. And then we have positive 4y plus 2y. So you have 4 lots of yo-yos and plus 2 more yo-yos. So you have 6 more yo-yos or 6y. And then you have 8 and 6, so that's just going to be plus 14. So that's my simplified version. The next, drag the orange dots to rearrange the like terms next to each other and enter the simplified expression. Okay, so 9x, do I see any more x's? Yes, I see the 9x and the negative 5x, so I am going to bring those two guys together. I will bring all the numbers to the back. Let's see, I will bring these two guys to the back. And then I have the y's together. So I have x's together, y's together, and the numbers together. Okay, so the x's 9x minus 5x. Okay, notice the way the negative sign came with the variable that followed. Okay, the number and the variable followed. Okay, so the sign always belongs to the number that follows. So do not lose the negative sign here. So 9x minus 5x is 9 minus 5 is 4. 4x. We are dealing with 4x. Okay, and then plus 7y minus 4y. We have 7 minus 4 is 3. So 3y. And then finally 10 minus 8 is 2. So it's going to be plus 2. Okay, let's keep moving. Alright, number 7. Which expression will be simplified to just one term? Well, to do this, we need to solve all of them, don't we? Okay, so let's try that. Okay, so what's 5xy minus 5x? Well, x and y, xy and x, are they same term, like terms? No, they're not. That means we cannot combine them to be just one thing. All right, so this is no. 14 plus 3y plus 7 minus 3y. Okay, well, 14 plus 7. What's 14 plus 7? That's 21. Okay, and then we have 3y. And remember, and negative 3y. Remember that negative symbol belongs to the number and the variable that comes after. So it's 3y minus 3y is actually plus 0. Comes to 0. And we don't have to even write the 0, do we? We can just write 21. So 21, this one simplifies to just 21. So that is just one term. We only have one thing, one term. Okay, so what about 4x plus 9 minus 3x minus x? Okay, so I see a whole lot of x's. I have 4x here. I have negative 3x here. So 4x minus 3x. So yeah, starting with 4 of the x's and you're taking away 3 of them, so you still have 1 remaining, 1 of the x's. Then you're taking away yet 1 more, so all the x's are gone, so you are left with just 9 again here. So this one is also correct. What about this? 8y minus 6x plus 2y minus 6x. Okay, so then I have the y's here. Let's deal with the y's first. 8y plus 2y. So how many y's do I have? I have 10 y's altogether. Okay, now what do I have here? Okay, so then I have the x's. So I have negative 6x and another negative 6x. Okay, negative 6 minus 6 is negative 12. So this, I actually have 1 term, 2 terms. So I have 2 terms, so this one does not work. So these two are the only ones that would work with just one term. So this would not be it. Great. Now it says create an expression with at least 6 terms that could simplify to 9x plus y plus 3. So right now, how many terms we have? We have 1 term, 2 term, and 3 terms. Okay? So then we want to come up with 6 that equals to that. So we have 1 term here, and another term here, and then finally a 3rd term here. So let's deal with the first term. Okay, so we're dealing with 9 x's. So what two x's could add or subtract to 9x? Well, I can do something simple like 6x. Oops, let me get my red color. So I could do something like 6x plus 3x, because I know that 6 plus 3 is 9x. Okay, so let's do for the y now. We are dealing with the y. So y is, we want it to end up with just 1 y at the end. Okay, so if I have negative 4y, what do I need to add to get finished with positive 1y? I can add 5y. Okay, and then finally I want to end up with positive 6. Well, I can do something really easy like 3 plus 3. Okay, so we do have 1, 2, 3, 4, 5, 6 terms, and they do add to this because that's how we figured it out. Okay, now you're going to be working on card number 10 to 19. This is card number 10. It says ways to the area. What are some ways you can calculate the area of the big rectangle on the left? So if you're I'm trying to figure out the area of this big rectangle. Okay, what is area of a rectangle? It's always going to be the whatever the length times width. So what is length? What is length? Length is, might be this length, how long this is, and the width could be this. Okay, so how long this is all together. Okay, so I know that this is all together 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this I know to be 11, and I know this is 7 here. So I can calculate this as 11 times 7. Okay, or I can think of this 11 as 5 plus 6, because I know that this is made up by 5 plus 6, and then multiplied by this 7 is really made up by 4 plus 3. Okay, is there another way? I could think of this as 5 times 4. This, I can just calculate the blue rectangle, 5 times 4, so 5 times 4. What about this orange rectangle? Well, I know that this is 6. This is, how many units is this unit? 1, 2, 3, 4, and we know that this is same as here. So 6 times 4 is 6 times 4. And this, for this orange rectangle, it's going to be, the width is 5, and the length is 3, or width is 3, length is 5. It does not really matter. So it comes down to 5 times 3. and then 6, this is 6 multiplied by 3 is 6 times 3. So I could actually add all these different rectangles and say, okay, 5 times 4 is 20, plus 6 times 4 is 24, and then 5 times 3 is 15, and then 6 times 3 is 18. Okay, do we get the same answer for all of them? Well, let's see. 11 times 7, what is 11 times 7? Is 77. Okay, what's 5 plus 6? 5 plus 6 is same as 11, and 4 plus 3 is same as 7. So it's basically exactly the same thing that we did here. So it's going to be 77 here as well. Okay, now the question is this going to be same as 77? Well, let's see. 20 plus 24 is 44. 44 plus 19 is 59. 59 plus 18 is indeed 77. Okay, so it all worked out to be the same. It did not matter which way we did it. Well, does it really make sense? Well, it's true. It makes sense because the big area is really somehow, you can think of it as sum of all these little rectangles, or you can think of it as just a big length times big width being multiplied to each together. Okay, so then let's move on to the next one. The area of the 11 by 7 rectangle here is 77 square units. The area can be expressed as a product, fancy word for multiplication of two sums. In this case, area is 5 plus 6, okay, plus times 4 plus 3. Explain why this makes sense, or ask a question if it is unclear. Okay, 5 plus 6. What does 5 plus 6 represent? 5 plus 6. 5 plus 6 actually represents this length, doesn't it? This length from here to there is 5 here, and then another 6. So it's really 11 together, but it can be broken down as 5 plus 6. So this is the length, and 4 plus 3 is the width, which is same as 9. So this is the length, and this is the width. Okay, so it makes sense that the big area is going to be length times width, and length is not just 11, but it can be broken as 5 and 6. So it's 5 plus 6, and the width can be represented as 4 plus 3. Okay, and the area of the rectangle can also be expressed as the sum, or fancy word for addition. In this case, the area is 20 plus 24 plus 15 plus 18. Okay, if I counted these little squares, I would have 24 here, and 18 here, and 15 here, and 20. And if I add them all together, then I would get 77 as well. Okay, so then let's keep moving. Alright, right now the rectangle has a total area of 100 square units. Okay, use the 4 draggable points to create a rectangle with 4 sections and total area of 48 square units. Okay, so then what do we need to do? When done, express the total area of a rectangle as the product. Okay, so we need to decide 48. How are we going to break up the 48? Okay, there are many ways. Okay, so I could do what times what. I can say that this is same as 48 can be broken up as 6 times 8. Okay, so if I chose the width to be 6 and the length to be 8, I can change this. I can move this to be, okay, so I want this to be 8 total, so I can make this maybe 3 and 5 to make 8. Okay, I want the total width to be 6. So how am I going to make that? Well, I can make 3 and 3 or 2 and 4, it doesn't really matter. Okay, so I can do 3 and 3 or 2